Bismillah Rahman Rahim. Welcome, dear professor and classmates, to my presentation. My name is Rehan Ullah, and this is my second presentation. And I am PhD student at the Department of Biomedical Engineering. Today is the paper presentation. So the paper that I want to present is the synthesis of silver nanoparticle by sedum adenotrichum extract and evaluating their antioxidant potential in albino mice. I am the first and corresponding author of this paper, and this paper has published in the Journal of Drug Delivery, Science and Technology. According to the quartile of the journal, it is a Q1 journal having 4.5 impact factor and index in Scopus and Science. The name of this journal is Journal of Drug Delivery, Science and Technology. This is my graphical abstract, and this abstract, it is a flow chart of all the experiment we perform. First of all, we collect the plant and then prepare methanolic extract of the plant. After that, we use HPLC to check which compound are present in our extract. Then we reduce silver nitrate to silver by using our extract. After that, we characterize by using different techniques. We characterize our synthesized nanoparticle, such as the technique of UV, FTR, etc. And we use our nanoparticle to check their antioxidant activity both in vitro and in vivo. For in vitro antioxidant activity, we use FRP assay and DPPH assay. For in vivo antioxidant activity, we use mice and dose for 21 days, and then SAT, SOD activity, GST activity, etc. So, an introduction and background knowledge. Bio nanotechnology is a multidisciplinary field of science that combine chemical, physical, and biological sciences. Mostly nanoparticles are 1 to 100 nanometer in size, and they are more efficient in small quantities. And the most outstanding property of nanoparticle is that they can pass through biological barrier. The unique property of nanoparticle is due to their large surface to volume ratio that gives nanoparticle distinct electrical, thermal, antiseptic, and antioxidant activities. We have different type of synthesis methods, but green synthesis here is more natural and also called biological method, and it uses natural products such as plant extract, fungi, bacterial byproduct, etc. The benefits of biologically synthesized nanoparticles are that they are biocompatible, eco-friendly, cost-effective, and they can degrade in environment. So this is called biodegradable. Not just like a microplastic. Microplastic in certain type of dyes, other product, they cannot degrade in environment. But for the biological synthesized nanoparticle, they can degrade in the environment. So it is a very important and outstanding aspects of the biologically synthesized nanoparticle. As I mentioned that they have unique properties due to their large surface to volume ratio. So due to this property, they can be used in biomedical application such as imaging, diagnosis, therapy of a certain disorder, and as well as they are used for the drug delivery system. In their therapeutic uses, they use as a carrier for small chemical and also used for biological macromolecule. And we can also put on some different type of messenger RNA, for example, COVID-19 vaccine for the drug delivery. They also use for the natural product formulation, and by using nanoparticle and natural product formulation, they enhance the solubility of the chemical, absorption, and bioavailability, because nanoparticle also it is a reservoir or matrix for the drug delivery system. In this experiment, we use sedum adenotrichum. It is a perennial succulent plant and rich in phenolic compounds, and this this plant can reduce silver nitrate to their respective nanoparticles. So we use cerium adenotrychum for the reduction of silver nitrate to their respective nanoparticles. The research goal of this study is to investigate antioxidant properties of biologically synthesized silver nanoparticle using cerium adenotrychum extract. And material and method, we needed silver nitrate, sodium borohydrate, DPPH, pyroglycol, trichloric acid, hydrogen peroxide, potassium hexocyanoferrate, and glutathione in the reduced form. Plant was collected from Dir Lower, KP, Pakistan, and extract was prepared by methanolic extraction method to prepare extract from Cerium adenotrychum leaves. Synthesis of silver nanoparticle, biological and chemical method used to synthesize silver nanoparticle. As I mentioned earlier, we have different type of synthesis method, but the most used are biological and chemical methods. And biological method, we use different biological byproduct, just plant extract, fungi, bacteria, yeast, etc. for the synthesis of nanoparticle. For chemical reduction method, we use pure chemical, but mostly the pure chemical are toxic, so we are shifting the trends from chemical synthesis to biological synthesis. After that, we synthesize a nanoparticle. We use different characterization measurement, just as UV visible spectroscopy, SEM analysis, FTIR, etc., to characterize our synthesized nanoparticle. After that, the antioxidant activity, we use DPPH ferric reducing power analysis for the in vitro antioxidant activity assay, and for in vivo antioxidant activity assay, where we use catalase, superoxide dismutase, glutathione, reduce or reductase, etc. For in vitro antioxidant activity. For this purposes, we use albinomyces strain called PALP-C as mammalian model for in vitro antioxidant activity. So the mice were randomly divided into 5 groups. Group 1 was called control group, and group 2 was given chemically synthesized after chemically synthesized nanoparticle, and after group 2, 3, 4, and 5 were dosed with the nanoparticle that synthesized through sedum. So the word SAGNP stand for sedum adenotrichum nanoparticle, synthesized nanoparticles. So the mice were dosed for 21 days, and each group contained 5 mice, and the treatment was continued for 21 days, and the dose was administered through injection through the tail vein. So these are the results and discussion. For HPLC analysis, we identified about 20 different compounds of different chemicals, and mostly they were these compound was mostly antioxidant compound, rich in phenolic compound, and chemifrol and quercetin, etc. So these are different type of different types of chemical compound that present in our extract, ranging from quinic acid to this last one. So after that, we identified all chemical present in our compound. We then synthesize nanoparticle. After that, we take UV of our synthesized nanoparticle. So we have different type of methods, as already I mentioned, biological and chemical method. We explored both method here, and for biological synthesis method, the peak observed for these nanoparticles were around 429 nanometer up the spectra. So it indicates that we successfully synthesized our nanoparticle. After that, we measure the stability and taking the UV after 1.5 month and after 3 months. So there was a little decrease in their absorption. It means some nanoparticle revert to its respective respective compound, just like we use silver nitrate as a precursor for the silver nanoparticle. After some time, some nanoparticle degrades through other compound or back to its precursor. So after a long time, they can degrade, but the stability duration for the synthesized nanoparticle through serum adenotrichum was about 3 months. So the particle size and shape, it is not the product of the UV, because UV just only confirm that the nanoparticle successfully synthesized and they show only the peaks. From this peak, we can observe that if the peak is sharp, it means the nanoparticle size is very small. If the peak is flat, it means that the nanoparticle size is larger. Uh, if there is no monodispacity or polydispersity, the peak also having different row or curves for different size of nanoparticle. So from this we can infer that our nanoparticle synthesized through this methods are monodisperse. So after that, we use FTIR analysis. FTIR analysis used for the determination of the chemical compound, for the determination of the functional group present in chemical compound. Let's see that we have different type of functional group present in the nanoparticle, in our nanoparticle, in our extract, just like CN, CH, COH group, CF group, etc., etc. But why we take both the FTR analysis of sedum adenotrichum extract and sedum synthesized AGNPs? The answer is that um, we use FTIR for the determination of functional group present in a or extract, but we synthesize our nanoparticle through this extract. It means if synthesized nanoparticle have some effect on our extract, there will be some stretching, bending, as well as diminishing of the bond. So it is true for the determination that our nanoparticle has been successfully synthesized. Let's see that it is A for the FTR analysis of sedum adenotrichum extract and B for the nanoparticle. After nanoparticle, let's suppose we synthesize successfully our nanoparticle. So we have different observation. Let's see, here is the there is no peak at this at the 2872 to and 2958, but after the synthesis of nanoparticle there are two peaks they have generated. It means that there are something done with the with our extract. What is then? The done is that our nanoparticle has synthesized and they have effect on our extract. So after that, we use antioxidant activity. For in vitro antioxidant activity, we use DPPH assay and FRP assay. Serum adenotrichum nanoparticle showed higher antioxidant activity than chemically synthesized nanoparticle, and as such also true for the FRP. Increase in absorption at 700 nanometer noted for each sample. All these were concentration dependent parameter. As we increase the concentration of our nanoparticle, the antioxidant activity also increase. So there is a statistically significant difference between the control as well as our experimental experimental groups. Let's suppose a chemical AGNP, it is our control in this case, and we want to use our 20 milligram of the serum adenotrichum nanoparticle, 30 milligram and 40 milligram. As we increase the dose, the antioxidant activity also increase with the dose. It is a dose dependent as well as concentration dependent. For endogenous antioxidant activity, we use superoxide dismutase assay. SUD helps convert superoxide into hydrogen peroxide. As you can see in this, um, The group 1 show it is the reading per the serum. Um, it is about 86 unit per ml in group 1, and it has been increased in group 2, and it is comparable and but group 3 and 4 are comparable, and group 4 also increased slightly. Okay, and then the liver SOD level. Per liver SOD level, the that is the control group. G1 is the control group. It is about 215 unit per ml, and increase to 348 in group 2, the SOD level, and group 3 group 3, 4 and 5 are comparable. The star show that there is statistically significant difference. So, for the superoxide dismutase activity, all data are presented as the mean with the standard deviation. And for the normality of data, we use the Levin statistics. If the p-value is greater than 0.05, it means the variance is same. There is no difference in their variance. So we can use ANOVA for this activity. So for the ANOVA, we use one-way ANOVA test and followed by a post-hoc Tucky test. The result of ANOVA show that uh, if the degree of freedom for this experiment is 4 and 20, and the p-value is less than 0.05, it means there is a statistically significant difference for both the serum and liver level as compared to the control group. As at the same way, we analyze the catalase activity. Catalase convert hydrogen peroxide into water and oxygen. And in the first group, as you can see that the serum and liver level of the catalase is very different. Serum have minute level of catalase as compared to the liver, because liver have contain lot of catalase. So in group 1, it is about 0.17 unit per ml, but it was a little bit increase in group 2 and then decrease in group 3, and group 4 and group 5, these are about at same level and are comparable with the group 3. So for also liver catalase level, it was noted about 2.85 in the group 1, but it was increase in group 2 and then decrease in group 3 and then increase and then decrease in group 5. Per serum, all data are represented as mean and standard error, and all data are normal. But for the liver, the data are not normal, and in other words, they are skewed. For skewed data, we don't use one-way ANOVA. So the other other test is the Kruskal-Wallis H test, because it is used for the skew data, and the effect is just like one-way ANOVA, but it is applicable to the non-parametric data or skewed data. At the same way, we also use glutathione S transferase or GST. GST conjugates with xenobiotics for proper disposal. The level GST in serum was about 2 micromole per ml, and it was decreased in group 2, then increase in group 3, and group 3 and group 4 are comparable, but a decrease was observed in group 5. So there was also a statistical significant difference when compared with the group 1. At the same way, the liver glutathione as transferase level was very high in group 1, but it was decreased in group 2, and group 4, 5, 4, 3, 4 and 5 were comparable. So it is table 2 comparative analysis of all obtained results. So for sample details, and we have two type of sample, chemically synthesized nanoparticle and silver synthesized nanoparticle, and sedum adenotrichum silver nanoparticle. This is the green synthesized nanoparticle. So we use characterization, just UV. UV showed that chemically synthesized nanoparticle have a size of 404 nanometer, and biologically synthesized nanoparticles show a size of 429, and then and 405 and 400. The stability was not studied for chemical AGNP, and the stability for SAGNP were over 3 months. And for FTIR analysis, we don't use this for FTI, for the chemical AGNP, and biologically synthesized nanoparticles show a high combination of carbon, nitrogen, carbon, oxygen, carbon fluoride, and carbon-carbon double bond, carbon-carbon double bond, and carbon and oxygen double bond were observed. Because this is a rich in phenolic compounds, so the functional group mostly are carbon, nitrogen, oxygen, fluorine, etc. These are the functional group present in the phenolic compound. For in vitro antioxidant and in vivo antioxidant activity, DPPH activity, FRP activity were used. As you can see, these are all compared with the average data obtained. So as we can see from this table that in 20 milligram the activity is 7.25% increase, but with the increase in the dose and as well as different type of nanomaterials, so chemical biologically synthesized nanoparticles with the dose of 20, 30 and 40, they show an increase, segmental increase in their activity for both DPPH and FRP activities. And in vitro antioxidant activities, SOD, catalase, and GST were used, and um, there their difference with the control group was obtained for their respective activities. So for 20 milligram, it was 61.8 some increase, 87% increase. For 20 milligram of biologically synthesized nanoparticle, it was decreased. It was increased by 37%, and for 40 milligram, it was decreased by minus 14. Minus 14 mean it was decreased. Per catalase, it was increased 35%, and it was decreased 34%, then increased 40%, and then decreased 53%. For GST activity, it was decreased by 57%, and there was a decrease for 20 milligram of SAGNP was minus 2%, mean it was decreased 2%, and there was a decrease of 1% for 20 milligram, and there was a decrease of 2% for 40 milligram. In conclusion, they have antioxidant activity because biologically synthesized silver nanoparticle exhibits more antioxidant activity, and they are biocompatible, cost effective, and eco-friendly. But there are some limitations to this study because further research needed to evaluate antioxidant activity in other models. Toxicity profile, it need to fully assess their toxicity profile um, to access all their possibility that what effect they cause to living organism or living cell. So it is important to fully assess the toxicity profile of silver nanoparticle synthesized through sedum adenotrichum. And also it is an immense use to determine the molecular mechanism underlying antioxidant activity need to be understood. After this presentation, I want to drop a review question. And the question is that what is the benefit of combining sedum adenotrichum extract with silver nanoparticle rather than using the extract by itself? Thank you so much for listening. Thank you.